Okay, so we talk about scientific notation mainly because this is probably the last place you will get anyone discussing it. Now, you use it in science, obviously, but by the time you get to college, most college instructors assume that you have a pretty good foundation with this idea. So we're just going to do the math, and the good news is that it's pretty straightforward, nothing too dramatic. Why do we have scientific notation? Because we have really big numbers. This isn't even that big of a number, 93 million miles. It's the average distance to the sun. Here's the mass of a hydrogen atom, teeny tiny number. So, you know, this would be something that we would find in astronomy. This would be something that we would find in chemistry. Planck length, this is physics. Diameter of electron, teeny tiny, also, again, chemistry. Mass of the sun, astronomy. So you get the idea. A lot of the sciences have very large numbers or very small numbers. So what we need to be able to do is get into scientific notation, and then we also need to get out of scientific notation. So we're going to talk about how we transform something into scientific notation. This format that we have here says n times 10 to the d, and the key here is n is greater than 1 but less than 10. That means n is going to be, you know, 1 point something, and it could be as big as 9 point something, but can't be smaller than 1 point something, can't be bigger than 9 point something. So it's not going to get up to 10, and it's not going to get less than 1. So that's really all it means. And when we think about it in terms of what does that look like, it means there's always going to be 1 digit to the left of the decimal point. And if you remember 1 digit to the left of the decimal point, and let me actually clarify that, 1 non-zero digit to the left of the decimal point, you'll always be fine. D, of course, is the exponent, and it can be positive or negative. And if you remember what positive and negative mean, you can get to the point where you say, okay, well, we know that if it is a positive exponent, it is a very small number, and we know that if it's a negative exponent, it's a very small number. If it's a positive exponent, we know it's a very large number. So these are things that we hopefully understand just based on what we already know. So when we look at this number, our first example that we're going to do here, we see that we've got a decimal place right here, and we can see therefore that this is a tiny number. It's certainly way less than 0. So we know that we need to have the decimal point with 1 digit to its left. So this is where that would move to. So the first step when we're trying to rewrite this into scientific notation is just to write this number. So we're going to write 9.1, and then the next thing you do is write times 10. Now what we're going to do is we're going to count the number of places that we moved. So we moved from here to 1, 2, 3, 4, 5, 6, 7, 8 places. And then we have to decide whether it's a positive or a negative exponent. The fact that it started out as a very small number tells us that it's going to be a negative exponent. So our number translated into scientific notation just like that. Now we've got a very large number, and again we locate that decimal, and we know that our decimal should be with 1 non-zero digit to its left, so this is where we're going to relocate it. So we're going to write 3.09, and then we're going to figure out how many places we moved. We moved 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So we have times 10. The exponent is 9. This was a very large number, so the exponent stays positive, so we don't have to actually put the plus in there. I'm just putting it in there for effect. And that we've just translated this big number to scientific notation. Now, one of the key things you remember is we're always having to count from the decimal. Now, no matter what has happened, I've counted from the decimal, If you don't see a decimal, you need to remember to put it in, otherwise you've got nothing to count from. So here, let's look at this example. So we don't see a decimal, so here's the decimal point. It's always at the end when it's a big number. I'm just going to add the 0 to make sure we don't forget it. And then we know that we're going to move the decimal, so there's one non-zero digit to its left, so that's where we move it. So we write 8.7 times 10, and now how many places did we move it? 3, 6, 9, 12, 13, 14. So we moved it 14 places. It was a big, huge, gigantic number, so the exponent is positive, and that's all there is to that. Let's do one more of these. So now, again, we locate the decimal. We can see that this is a tiny number. We want to relocate the decimal, so one non-zero digit to its left. So we write 1.3045. Now, if it wants you, if the information tells you to round, you round. Otherwise, we're just going to keep it. Times 10. How many places did I move the decimal point? 1, 2, 3, 4, 5. And it was a small number, so the exponent is negative. Now let's go ahead and translate a number that is in scientific notation back into standard notation. So we've got 4.6 times 10 to the negative 7. So when we're translating back, the first thing that I would do is tell you to write the number 4.6. Now this negative tells us it's a small number, so the zeros are going to go to the left. I usually just write down 7 zeros, so 3, 4, 5, 6, 7. When I say I write down 7 zeros, I write however many numbers are in the, however many zeros are in the exponent. So now I'm going to count 7 places. 1, 2, 3, 4, 5, 6, 7. So our standard notation is 0.123455. 1, 2, 3, 4, 5, 6, 4, 6. And that's all there is to it. So if you had something like, 30 is 3.6 times 10 to the 8. So now we see that we've got a positive exponent here. So again, we write 3.6, and now I'm just going to add 8 zeros to the right. And I know that I'm going to move the decimal point 8 places, make a big, huge number. 2, 3, 4, 5, 6, 7, 8. So we have 3, 6. We have 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. I'm going to put in my little commas to mark it. And there we have this number in standard notation. And that's all there is to it.